Sodan, welcome back with me, Miss Fatih Purba, and today I'm going to review Meet SA2 Science for all of you. So please watch this video carefully. If you still don't understand, you can ask me personally. Remember, for our Meet SA2 Science tomorrow, the topic will be start from chapter 7, 8 until chapter 9. The first topic that we are going to discuss is about acid, alkaline, and neutral. If you are going to discuss about this, you need to understand about the pH scale. The pH scale starts from 0 until 14. 0, the example is battery, 1 stomach acid, 2 lemon, 3 vinegar, 4 tomato, 5 coffee, 6 milk, 7 water, 8 blood, 9 baking soda, 10 stomach tablet, another word we call as antacid, 11 ammonia solution, 12 soap, 13 bleach, and number 14 is drain cleaner. 0 until 6 is acid, while 7 is neutral, the example is water, 8 until 14 is alkaline. Okay, I repeat again, 0 until 6 is acid, 7 water, 8 until 14 is alkaline. So the example of acid is battery, stomach acid, lemon, vinegar, tomato, coffee, and milk. Example of neutral is water, and example of alkaline is blood, baking soda, stomach tablet, ammonia, soap, bleach, and drain cleaner. Usually all cleaner is alkaline. Now for the pH scale, just now we have divided 0 until 6 acid, 7 neutral, 8 until 14 is alkaline. Another word we call as base. So 1 until 3 is a strong acid, 4 until 6 is a weak acid, 7 neutral, 8 until 10 is a weak alkaline, 11 until 14 is strong alkaline. What is the difference between acid, neutral, and alkaline? We can start from the pH. Acid, the pH is start from 0 until 6, neutral 7, alkaline 8 until 14. How about the taste? If you try to consume acid, neutral, or alkaline, you can determine it from the taste. If acid, the taste is sour and sharp, while neutral is tasteless, alkaline is bitter and soapy. How about litmus paper? If the litmus paper you put into the acid, the color will turn into red. If you put into the alkaline, the color will turn into blue. And if you put into neutral solution, for example water, the color will turn into purple. And about universal indicator, if you put this into the acid, the color can start from red until yellowish green. But if you use universal indicator to check neutral, the color will turn into green. And if you use universal indicator for alkaline, the color will become blue into purple. Can you find the difference? Now let's see from the picture. This is universal indicator or pH indicator. If we put this indicator into the acid, the color will change into red. So this means this is acid. If you put into the neutral, the color will turn into green. And if you put into the alkaline, the color will turn into blue. This we have two types of litmus, red litmus and blue litmus. So this red and blue litmus, we try to dip into the alkaline, acid, and neutral. We can see the difference. If you dip the litmus paper into alkaline, the color of red litmus and blue litmus will turn into blue. While you try to put red and blue litmus into acid, the color of litmus paper will turn into red. And when you try to dip red litmus and blue litmus paper into the neutral solution, the color will not change at all, or the color will turn into purple. Can you find the difference? Acid and alkaline in our daily life. Antacid is the medicine we are going to use to neutralize the acid in our stomach. As we know, the acid in our stomach is hydrochloric acid, and this acid is a strong acid. So to neutralize the strong acid, we need alkaline in the form of antacid. Now we continue about rocks. Scientists who study about rocks we call as geologists. We have three types of rock, that is igneous rock, sedimentary rock, and metamorphic rock. We will start from the first process for the igneous rock. Igneous rock are coming from the magma that cools down. Magma that cools down under the surface of the ground we call as intrusive igneous rock. While the magma go out by volcanic eruption, the lava will cool down and become extrusive igneous rock. So I repeat again, intrusive igneous rock if the magma cools down under the surface of the earth, okay? While extrusive igneous rock if the lava cools down outside of the volcano. That we call as extrusive igneous rock. So from the igneous rock, now we are going to go to the sedimentary rock. So how the process? The process is we call as weathering and erosion. So the igneous rock, because of weathering and erosion caused by wind, water, and ice, this rock will breaking down into smaller pieces that we call as sediment. Compacting and cementing. The sediment just now they already broken down will get into the water, and then the sediment will be accumulated and then pressed together to form sedimentary rock. This process we call as compacting and cementing. The sedimentary rock turns into metamorphic by heat and pressure. Heat from the magma and pressure from above layer. When the metamorphic getting deeper, deeper, and deeper until this metamorphic get into the magma, the metamorphic will be melting and turns into magma. To simplify the explanation, we can see the rock cycle. We can start from the magma that cools down. So magma cools down will turns into igneous rock. Remember, we have two types of igneous rock, intrusive igneous rock and extrusive igneous rock. This igneous rock, because of weathering and erosion, this igneous rock will turn into sediment. And then this sediment will get into the water, and by the process of compaction and cementation, this sediment will turn into sedimentary rock. After a million years, this sedimentary rock will get in deeper until get the heat from the magma and pressure from the above layer. So this sedimentary rock will turn into metamorphic. This metamorphic, after another million years, will get in deeper, deeper, and deeper, until finally the metamorphic will get into the magma, melt, and then become magma again. And then because of volcanic eruption, this magma will go out and then cools down and then become igneous rock. This is we call as rock cycle. Fossil layers. How we can identify which one is the oldest and the youngest fossil? We can see from the position of the fossil. If the position of the fossil is quite bottom, in the very bottom position, means that is the most primitive fossil or the oldest fossil. While the position of the fossil, if you can find it, is above, means they are younger than below layer. So in this position, the oldest fossil are jet, and the youngest fossil is Phi. So if I ask you to arrange in order from the oldest to the youngest fossil, that is Z, Y, X, W, and Phi. Geological time scale. Geological time scale are divided into three eras, that is Paleozoic, Mesozoic, and Cenozoic. The oldest era, that is Paleozoic. And the youngest era or the current era that we are living now is Cenozoic era. While the era where dinosaurs lived, that we call as Mesozoic era. The age of the earth. As we know, the age of the earth is around 4.6 billion years old. The structure of the earth. We have three layers of earth: crust, mantle, and core. While core, we divide it into two, inner core and outer core. Continental drift idea. The scientist who found this idea is Albert Weiner. All of the continents in this earth are coming from one big continent that we call as Pangea. And this Pangea will separate and drift apart. So this idea we call as continental drift idea. Now we go to chapter 9 about force. Force is a push or pull upon an object. And the equipment we use to measure the force we call as force meter or Newton meter. How to count weight? Weight is mass times gravity. When you are on the earth and when you are on the moon, you will have different weight, but you still have same mass. For example, this astronaut have body mass is 120 kilogram and body weight is 1200 Newton. How he can have 1200 Newton? Weight equals mass times gravity. His mass is 120 and the earth gravity is 9.8. But to make it easier for you to calculate, we just run out become 10 meter per second square. So how to get the weight is mass times gravity. The mass is 120 and the gravity is 10. So 120 times 10 equals to 1200 Newton. But when this astronaut go to the moon, he still have the same body mass, that is 120 kilogram, but he have different weight. His weight is only 200 Newton. Why only 200 Newton? Because moon gravity is only 1/6 of earth gravity. So your body mass are still same wherever you live, but your body weight are changed depends on where do you live. So the one that can change is weight, not mass. Now we discuss about force arrow. If 10 Newton, we push 10 Newton to the left and then we give another 10 Newton to the right, the total of the force is 0 because 10 Newton to the left, 10 Newton to the right, so the total is 0. But if we give 10 Newton to the right and another 10 Newton to the right, so the total force, because they are same direction, is 20 Newton. The third case, if 10 Newton to the left and 8 Newton to the right, if we want to find the total force, the answer is 2 Newton to the left. Why 2 Newton to the left? We can see that the force to the left is more compared with the force to the right. So the box will move to the left 2 Newton. Pushing book or pushing car. When you are moving the object, for example like book or car, there is 4 force applied in this object. First is friction, second is normal force, the third is weight, and the fourth is the force itself. I repeat again, there is 4 force, that is friction, opposite direction with the direction of force, normal force, and weight. When the book stop moving or stay in the table, means the normal force are equals to the weight. But when the book are moving, we have additional 2 force that we call as force itself and then friction. Remember, friction always opposite direction with the direction of force. So if the books move to the right, the friction will move to the left. Archimedes principle. The buoyant force or upthrust force is equals to the weight of the displaced water. So as we can see, this is 7 actually. But when you try to put this object to the water, the weight of the object become 4. Means the buoyant force or the upthrust force of this object is 3. And we go to the last topic, that is Galileo and Leaning Tower of Pisa. Galileo is a very famous scientist who do the experiment about 2 different objects. He tried to throw 2 different sizes of ball from the top of Pisa. Most of people think the biggest the size, the faster it's move. But actually, even they have a different size of the ball, these 2 balls will land at the ground in the same time. This is because of air resistance. When the objects are bigger, they have more air resistance. If the object is smaller, they have smaller air resistance. So these 2 objects will land in the same time. Okay, that's all about my explanation. I hope this video can help you to understand the topic for our mid-test tomorrow. If you still have any question, you can ask me personally so I can help you to understand more about this topic. Thank you for watching my video. Don't forget to like, comment, and subscribe.